Welcome to the distance sensor with the Arduino Uno project. Uh, we are using the Arduino IDE 2.0.3. This is the sketch that I made up. Uh, one of our wires is plugged into the A0 port. That's our analog in pin. We are using a serial of 9600 nods, and the delay is 500. It doesn't necessarily need to be this high, but just so that the sensor has time between picking up the different calculations, I'm giving it a little bit extra of time. If you want to look at the board itself, this is the Arduino, obviously, with this being the distance sensor, with the wires going into it. There's a wire into A0, the ground, and 5 volts. So if we want to, just to be safe, verify and compile the sketch, upload it as well to the board. And now if we look at the serial monitor, there we go. I did make the values print on a new line. Right now my hand is nowhere near it, but if I move my hand closer to the distance sensor, the values will start to go down until I'm eventually basically on top of it. And then when I let my hand go back up, the values go back to increase. So the name of this project is basically to take these readings, instead of displaying them on the serial monitor, we want to display them as graphs in MATLAB. This is the MATLAB script I wrote. For the different x and y, we want them to have their own vectors along with the velocity and acceleration. I could check for the serial port list, see what's available, but I already know what port, the COM3 with 9600. So here we are opening it, the connection, and we want to plot only 100 points of data, and the data comes in the form of strings, so we want to convert those to numbers before taking the data. Here we are doing derivations to make it go from a position plot to a velocity graph, and similar here from the velocity to acceleration. And then to plot them all at once, we are using subplots, with the first one being distance, with the x label being time in seconds, y label being from 0 to 255, the maximum y value, and similarly so for the velocity and acceleration. At the end, we close the connection. So now let's run the MATLAB script. For the calculations themselves, I did move my work to a different script, which will eventually have more information, but if we click run, this is a look at our distance graph with our velocity and acceleration followed behind. We also then did equations for the second order approximation as well as the least squares fit. That's basically the trend line of the data. There's a bunch of calculations with taking the values, the squares, cubes, sum of them, etc. And the results will be displayed over top of the plots themselves. For this, I did get rid of the acceleration plot, but this is the line of best approximation. And going back to my file, for some reason it's not showing in my current MATLAB script. I did have to re-download it, and my script might not have saved fully. But in the command window, it displayed the A1 and A0 values. And although it isn't explicitly stated here, the 173 is the believed value for my A2, and that gives you the A0, A1, and A2 that is needed for the second order approximation that we want to do. Here's just another screenshot of the plot with the trend line, and overall I thought that the order of polynomial of 1 would be the best for the given graph. Thank you.